All right, so the floor is yours. We'll hold any questions until the end, and then whenever you're done, we'll take some questions. All right?
Sounds good. So I have about an hour.
Yep, we've got until about 7:30. So
Okay, sounds good. All right. So I just spent the last few minutes figuring out where Omaha was. I was just wondering if I've been there, but I haven't. I've been to South Dakota though, so that's not too far away. But anyways, um, so I'll just get going, and I'm sure if there's something wrong with the sound or anything, I hopefully someone will let me know. Uh, and hopefully you can see my screen as well. Yeah, I'm sure Bo will chime in if something's wrong. So yeah, my talk today is I've called it real life service management automation. SMA is, I guess it's kind of it's a bit of a buzz at the moment. Partly because of Azure automation, which is pretty much the same thing as SMA. So a lot of this stuff I'm talking about today will apply to Azure automation as well. And I guess also partly because a lot of us have been looking for some kind of automation product to help us organize all our PowerShell scripts and have them run in a more controlled fashion than we've used to do. Um, that said, there's some good and bad with SMA, and I'm on my third SMA related project right now, and some customers we've deployed quite complex automation projects using SMA. We have, I think, a couple of customers we've delivered around 10,000 lines of code with, and so I guess my talk today is about what works, what doesn't work so well, and how to maybe get around some of those shortcomings. Um, about me first, my name is Trond Hindenes. I work at Crayon in Norway, which is one of the major Microsoft partners here in Norway. I do a lot of Office 365 and Azure projects, and I also do tons of PowerShell and SMA stuff. So that's basically me. Um, if there's two things I want you guys to kind of take away from this hour, it's firstly that SMA it's a cool product with a ton of cool features, but it does sadly maybe rely on PowerShell workflows that kind of make it might be not the right product for complex automation projects. And I guess if I knew now, or if I knew then what I know now, maybe we would have looked elsewhere for some other product when we did our large automation projects. But so yeah, I'll go through the cool stuff and not so cool stuff, and then I'll do some digging into the limitations around workflows and some best practices at the end. I'll just try and keep an eye on the link window here, and as long as there's nothing there, I'm assuming it's all good. I don't know how much you guys. I don't know if you've seen the product or worked with it at all, but I'll just do I guess a quick dive into it. Um, Let me just first start by spending 2 minutes inside the product itself. SMA is part of System Center. It's on the orchestrator media. It doesn't have anything technically to do with orchestrator apart from the name. When you install SMA, it doesn't actually have a GUI. So if you want a GUI on top of SMA, you install or you use the Windows Azure Pack, which is a free download, which is a Microsoft's private cloud offering, I guess. and Azure Pack lays on top of SMA, as well as some other products. Virtual Machine Manager is maybe the most important one. So anyway, after you've installed SMA and the Azure Pack, you can register the SMA endpoint into Azure Pack, which is what I've done here. SMA will by default install a web service at port 9090. So you register that, and you're pretty much good to go. And in addition to the web service, there is this role which is called a runbook worker, and you can have one or many of those, and those are the actual nodes that will execute your scripts or your runbooks. They're not particularly intelligent, so there's no notion of failing over. So if you have downtime on one of those runbook worker nodes, there's still going to be assigned jobs. So oftentimes there's not a big reason to have multiple runbook workers. You don't get any high availability out of that in any way. So the only reason to scale out is if you have a lot of concurrent jobs and start taking your VM or physical server to its limits. But in any case, after you've registered this endpoint, you get two things. You get a runbook library, and a runbook is basically a PowerShell workflow. And then the other thing you get is this asset store, which is kind of interesting. And I guess the assets thing is one of the really cool features inside of SMA. You have a couple of different types of assets. I'll get into modules in a few seconds, but maybe the one we use the most is variables and credentials. And the idea is quite simple. Instead of hard coding variables and credentials into your scripts, you add them to this asset store, and then you're able to receive them inside your workflows. So that if you have a service account or a variable that changes, like the other day, we had a change in some SMTP server, I think, and luckily we had used the variable. We have placed that inside of a variable here, so we didn't have to change any script or anything. We could just go in here and update the value for that SMTP server, and everything kept on working. So that's one of my favorite features, I guess. Another type of asset is a central module library, and the idea is that if you have multiple runbook workers, instead of having to manually deploy the PowerShell modules that your runbooks are going to use to each of those runbook workers, you can upload them to the asset library, and SMA will basically push them out to the runbook worker that will execute your script, so that they always have the right module. Now there's a limitation there, because I'll go into workflows and inline scripts a bit later, but basically a PowerShell workflow it doesn't have to, but it may contain an inline script, and an inline script is basically just a piece of regular PowerShell code which executes inside a workflow. And those SMA modules are not accessible inside of inline scripts. So if you need to use a module inside an inline script block, you need to have that module installed on the file system on the runbook server, or on whatever server the inline script runs on. So while SMA modules might seem like a really good idea in theory, in practice we usually end up with a lot of inline scripts, and that kind of lowers the value for that a bit. But depending on how you design your workflows, you might be able to get away without inline scripts, and if you do that, then those SMA modules might be a really good idea. And the modules are quite easy to make. You basically just take a regular PowerShell module folder and zip it up, and then that zip file will be uploaded. Was audio good now? Okay, nice to know. So yeah, you basically zip up the module and then you upload it. Yeah, so it's basically a browse, and that also works for Azure Automation. So if obviously inside of Azure Automation you don't have any control of the actual VM where the automation product is installed, so you can use this. So you can use the SMA modules to gain access to whatever PowerShell module you need. And I've tried uploading like complex PowerShell modules. I tried the Amazon Web Service module, and as far as I know, everything works just fine. There's some limitations around .NET Framework out of Azure Automation, but I won't go into that big of a detail. Oh, I will certainly do that. So I'm not sharing now, Bo, and I'll try and just reshare my desktop. How's that? Can you guys see my screen now?
This is loading. Hold on. It like randomly dropped off.
Oh, okay.
We're good now.
Yeah. Just let me know if it happens again. Yeah. Yeah, I'll just continue. Another cool thing is that SMA, since it's implemented as a web service, it's really easy to use that web service for pretty much whatever. So instead of when we build these SMA projects, customers most often want some kind of GUI on top of that. They don't want to have to send their users to the Azure Pack portal in order to start a runbook. For instance, right now we're building a C# MVC project, and it's literally 2 lines of code to execute or to start off an SMA runbook from inside of C#. And we've also used Visual Studio Light Switch, which is kind of like a GUI designer for data-driven applications, I guess. So yeah, pretty much anything that can talk to web services is a good bet for talking to that OData service to kick off web services and get report back on how they're doing and if they're stopped or whatever. So that's really good as well. And then obviously there's some oddities, and most of these are coming from the fact that SMA doesn't use regular PowerShell. It uses PowerShell workflows, and I guess workflow is a session of its own, or maybe a course, so I won't get into too much details. But I had never used workflows before I started working with SMA because I just didn't see the reason. So as these projects progressed, we've been picking up more and more bugs and oddities around how workflows work, and I just wanted to share a couple of them. The first one is what we call workflow session lingering, which has kind of a strange effect in a couple of situations. So hopefully you guys can see my screen. I just want to show this one quickly. Not hearing any complaints, I'm assuming that's good. We're good, good. So this is a funny one, and this actually cost us, I don't know how much time before we were able to kind of chase down the root cause. But the idea in SMA is that you kind of create code blocks. So if you have a large number of runbooks that will, for instance, create a computer account or a user account in Active Directory, instead of repeating that code inside of all of your workflows, you create this simple workflow that will basically just create the computer accounts in the correct way, and then you call that from your other workflows. So it's what's called nested workflows, I guess. So they try and, yeah, I guess this notion of code reuse is good in theory. So I have these two workflows. There's this one inline script inner and inline script wrapper, and this wrapper will basically just call the inner script. So this guy is what I will call, and then this workflow will again call the other. So this inner workflow takes two parameters, the service name and a computer name. And what it will do is that it will start executing, take those two parameters, and then I will use this asset store to get an admin credential, and the commandlet for doing that inside of a workflow is get automation PS credential, and then the name of that credential, the name of its name in SMA. And then I'll switch to inline scripts running on the computer name that was passed with the credential I picked up. And then the method you use for sending parameters from the workflow into the inline script is to use this using directive. So here I say service name equals using service name. So I basically take this guy. And what we saw happening was that these inline scripts started to pick up the wrong parameters when we called them multiple times inside the same workflow. So what I do here is I'll basically call the same workflow twice. And the first time I ask for the spooler service, and the second time I ask for the bit service. And then obviously this guy gets executed twice with different parameters. So let's just kick this guy off and see what happens. So I'll just hit start down here. If your workflow takes a parameter, you get prompted for those parameters when you hit start. But this guy doesn't, so it'll just start up. And it sits in a starting state for a couple of seconds before it starts running. And you can actually see it running. It basically kicks off this sandbox process for each running runbook job. So the code is executing inside this sandbox gets a run space that executes the code. So that shouldn't take terribly long. So what happened here is that the inner script says that it got those parameter spooler and computer my domain controller, and then the inline script reports the correct one. But then on the second run, the workflow recognizes that it got another name for the service parameter, but the inline script actually thinks it got the same service name as the first run. And the reason for that is basically that when we when we use inline scripts or when we execute inline scripts on a remote computer, that opens a remote session which doesn't get closed when the code has finished running. It will actually live for a couple of minutes, and as long as that session lingers, if you try and specify the same parameter name with a different value, that just doesn't get picked up. It looks like they fixed this in PowerShell version 5. At least it's working differently in the preview versions we have access to. But for 3.0 and I think 4.0 as well, this is basically a bug. So we just figured out that, hey, if we just wait for 2 minutes until that session dies off, then everything seems to be working. And that's just a good example of the bugs that are currently in PowerShell workflows. They're quite weird and kind of hard to track down. So it's a good one to be aware of. So we can just edit this and add that start sleep thing. There is this authoring pane inside of Azure Pack GUI that you can kind of check out your scripts and edit them. And I can save this guy and publish, which kind of replaces the old published version with this one. We don't use this in production because it just doesn't scale to sit in a web GUI and edit runbooks when you have tons of them. But for quick edits like this, I guess it does the job. So now we can come back to this later, but you'll see that at this time it'll figure out the right parameter values and report back the right service names. The next one is, we found this a bit more recently. This has not been fixed in PowerShell version 5 as far as I know. And I can probably just code some simple. So I do our workflow 1, workflow 2, workflow 3, and then call these guys. And then here I'll just say right and just execute this guy. So workflows behave a lot like, or you code them a lot like functions, as you can probably see, although they execute differently. So I executed number 3, which called number 2, and number 2 called number 1, and all that does is output some stuff. However, in SMA, error handling is really important. So what you probably want to do is do some error action stop or something here. And so here's the bug. If you have 2 or 3 levels of nesting, so like here 3, 2, 1, you're not able to use error action anymore. And in my opinion, that's a huge bug in PowerShell workflows. And like I said, I don't think this fixed this for version 5 just yet. That's kind of a biggie, and that also cost us considerable amount of time to chase down. Yeah, so it's the same thing here, basically. You're not allowed to use error action if you have 2 levels of nesting down, which kind of goes against this code reuse thing. It kind of makes it harder to to write these small blocks of runbooks that does very specific things because of the need for error handling. And so from these projects, we learned some stuff. When we started the first project, we actually started just writing or pasting code into this web editor inside the Azure Pack portal, but it simply doesn't scale. And so what we've learned, I guess, like all projects learn once the code base reaches a certain size, what you need is to properly manage that code using Git or some other version control system. Now, keeping these scripts in a folder by themselves is not a huge problem. The problem with that is that, say I wanted to publish these 3 workflows to SMA. The first thing I would need to do is to split them out into separate files. So this guy would have to go in this file, and it'll have to be called PS1, and then this guy would have to be named 2.ps1, and so on. And also the order in which you publish these is really important to SMA. So for this code to work, I would need to publish this workflow first, and then this, and then this lastly. Because if you try and publish a runbook or a workflow that contains a reference to another runbook that SMA doesn't already have, it'll refuse to publish that workflow for you. So we needed to actually build some scripts that will analyze a folder structure of PowerShell files and figure out the right order in which to publish them to the SMA server. So here, for instance, if I just add some other, I've already published these 2 into SMA. I'll just add this. And if I do sync runbooks now, it'll actually scan each file in my runbooks folder and figure out the right order in which to publish them. Oh, I know why that happens. Oh, that's not right either. So it doesn't matter. So it says here that, hey, the wrapper is updated and it will be republished. However, if I add a comment to this inner, if I update the inner script, that means that we'll have to publish or update this one first. And then because this has a reference to it, we'll need to update that one afterwards. I rerun this guy. It should do that in the right order. So it found a diff in the inner script, and then because of that diff, it'll actually also republish the wrapper. So we basically spent some time writing this function that will parse each workflow and figure out the references and then figure out the correct order to publish them. And that's, I have the links for that later in my slide if you guys want it. So doing that, we've been able to move away from using that this web-based editor, which I just barely showed you guys, and instead we develop everything locally using ISE, and then we check that into Git just to keep a version control of it, and then we publish it using these scripts. We actually had a situation where the first time I was going to demo one of these pretty big workflows, some Hyper-V deployment stuff. It actually didn't work because of some change we put in. So, and because we had everything in source control, we were able to just quickly rewind the whole code base to a couple of days before and republish everything, and then it worked. And I don't think the bosses even noticed, although we spent a few minutes doing that. So that was a real lifesaver for us. Another lesson learned is using a naming standard for these assets. And the reason for that is that in this asset link, you have modules, credentials, variables, and in some cases, these schedules living in the same view. So the ability to just, we use var basically for variables, and we often use cred for credentials. So just the ability to prefix these assets with some kind of standardized lettering really helps us. Just for the simple reason that they're all in the same view, so you need to be able to separate them in some way. Because what can I say? The web GUI leaves a couple of things to be desired. There's no filtering here. Sorry. And lastly, maybe most important, you need robust error handling. When you write scripts that usually just run on your own computer, you're basically at the screen all the time. So you're able to pick up if something bad happens. Whereas in SMA, your code basically runs headless, so you need to be a lot better at handling errors. And I guess the consequence of an error inside of an SMA runbook might be potentially a bit bigger than code running on your own computer. So you need to step up your error handling game, I guess. So yeah, my last part is about writing robust workflows. And I thought I'd just start off by taking a look at how PowerShell does errors, basically. And I'm assuming some of you guys have seen this already, but I'll just bring up. Whoa. Here it is. No, that's not the right one. Bear with me for a second here. Oh, no problem, I can just code it. So inside of PowerShell, you basically have two types of errors. You have terminating and non-terminating. And a terminating or a non-terminating error is basically, let's say, get service something. All right, host. So a non-terminating error is basically an error that makes the script not stop. The script just continues to run. And Microsoft has documentation on why some errors are considered terminating and some are not. So in this guy, I just said get service something, and I got a non-terminating error back. But the script just kept on running, so it still executed my second line and outputted hello down here. Whereas a terminating one might be to try and write to a file that, or to a drive that doesn't exist. So if I say new, then type file, set something, and I don't have a set drive. So that should, actually still continue running. Oh, that's funny. That might be because of the ISE. Oh, okay. So one way to figure out if an error is terminating or not is to put inside a try block. So I'll just do that instead. So basically, a try catch block is if you get a terminating error inside a try block, it'll execute this catch block. Whereas if you get a non-terminating error inside of a try block, it will not execute the catch block. So if I execute this one, okay, so that means that it's a non-terminating error actually. What we can do is instead we can use if I say error action stop, that's the terminating one. So it executed hello. And if I uncomment that, then write error is a non-terminating. And try catch blocks don't catch non-terminating ones. So if I write this, then it shouldn't execute this part. So it just caught an error. So we use try catch blocks a lot to kind of deal with errors, and obviously in regular PowerShell you use error action a lot too, but you're kind of limited inside of workflows when it comes to error action because of that bug. And obviously you may, you may just decide that we're never gonna do three levels of nesting. We're always gonna do one or two, but never three. But that will kind of limit your ability to reuse code, so it might not be the best way forward. So anyway, inside of PowerShell you have two types of errors. That was my main point. The other thing is streams. As far as PowerShell is concerned, you need to be aware of the standard out stream as opposed to the verbose stream. And I'll just do some quick demo here. So say you wanna, that's a bad word, line script, and then get so say you have an inline script and you need to capture some data from that inline script. So if I just say my var here, any output from that inline script gets stored inside of my var so that I can use it later. My var start. And I'll be something like that. So this guy should work. So I get running back. A very common problem with these inline scripts is that you have what we call chatty commandlets that return data that you don't need or you don't want, but they're still there. And a good example of that is new item. This time I'm going to use an actual path that exists. So I'm just going to create a file on my desktop. Oh, I can't do that. Can't do that, so I'll just get to so if I execute this one, this is probably not going to work so well. Oh, it actually did. So the problem here is that new item will actually output some stuff. and I know why this worked. So the only thing I really wanted from this inline script is the result of get service spooler. But since new item actually returns stuff to standard out, that gets included in my var. So at this point, my var is this mumbo jumbo object that consists of both the result from this commandlet and this. So it's super important to be really thorough when you're writing stuff inside of inline scripts to make sure that you don't get any output that you don't want. And you can mute them by either do out null, or even better, you can just do null equals. So that took care of this. Of any output from this command that will basically be sent to null, so it just doesn't get sent anywhere. Instead, what you can do, if you need some kind of logging or output from these script blocks, you can. We usually do verbose instead, so I can do write verbose creating the file, and then I can add some verbose preference here. So at this point, even if I do write verbose, that's a different stream than standard out, so that doesn't get included in my var. So this guy should still work. I just got some nice information back. And in terms of SMA, you can control whether or not a runbook will output verbose information. So if you click, this is one of my runbooks, and on the configure tab, you can actually tell it to log verbose or not. So this is essentially the same as setting verbose preference for the execution of that runbook. So most of the time we will set this to true. And it's worth noting that if you have nested workflows, only the outer one, the workflow you actually call, will so the value from the workflow you actually call, that's where you need to set this. So SMA won't actually log running of those inner workflows. They will just be executed inside of the outer workflow. So if you look at the example I ran earlier, which should be done by now, what did we call it? This guy. I guess we can check that. Yeah, I don't know if we checked that earlier, but now after I added that start sleep for 2 minutes, it actually got the right service back. So that's how to handle that bug. What I wanted to show was that this inner one, let's see. So as far as SMA is concerned, this inner workflow that I'm just referencing has actually never been executed. So SMA will only do logging and kind of register execution of the outer workflow, or the ones you call. So any workflow you call inside of that will not get any logging or whatever. So that means that if I wanted some verbose information from this code, I will just configure verbose logging on the outer workflow like that. So yeah, that was streams. And then lastly, I spent some time working on, hey, how we need to kind of create not a framework, because that's a really strong word, but we create this skeleton, which is basically how we develop these workflows that kind of fit into SMA, that take into account the limitations around error action, and still are able to provide some information to the parent workflow on whether they failed or not, and if they failed, what kind of error we got. So I thought for the last 15 to 20 minutes, I thought I would just go through that skeleton, and then after that we can open up for questions if there are any. And I think I'll just use some actual code here. So this is a project we're working on. It's basically some runbooks that will stop and start Azure VMs. And the reason we're developing this is that my customer has a ton of developers, and they don't want those developers to have any actual access to Azure by themselves. So they have this portal where they can basically start and stop their VMs. And whenever they start or stop a VM, that actually kicks off an SMA runbook that will pick up the necessary credentials to log on to Azure and perform the actual start and stop. So we have two workflows here for what we call invoke power state. So that's the wrapper one, and that's the inner one. And we came up with this naming standard where we basically say that any workflow that's called a wrapper, those are the ones that we actually execute from some other system or whatever. And that also enables us to put some monitoring around any workflow that has wrapper in its name will basically be picked up by monitoring, made sure that they don't fail. So this guy takes ID of a VM and the operation we want, which is basically shut down or power up. Ideally, you would probably want to use parameter validation like we do in regular workflow. So use this validate sets to make sure that the only values they would type in here would be start or stop. But you're not allowed to do parameter validation. So you're not allowed to use validate set inside of SMA workflows. And if you try and publish a workflow that uses validate set, it'll tell you that basically you're not allowed to do that. So what we do here is that we basically take these parameters and we set error action preference to stop, and that will and once you set error action preference to stop, any non-terminating error will be call it converted to a terminating error, which makes it a lot easier for us to handle, because we only have to work with one type of error instead of two. And then I also set verbose preference to continue so that I get verbose logging. The next thing I do is to actually just write out the name of the workflow. And the reason we do that is that when we have a lot of nested workflows, when you look at the verbose log, it's really nice to be able to see where you failed if the workflow failed. And then this guy just calls a web service to get some details around the development environment and the VMs that are part of it. And then what I do, any child workflow I call will output this object. And I guess I should switch to the inner one. I won't go into details about this, but I will show this one is kind of the main one. So So this is the workflow that will actually log on to Azure and adjust the power state. So what we do here is the exact same thing. We set error action preference to stop, verbose to continue, then we log the name of the workflow, and then we log some other information. The next thing I do is I create just an empty PowerShell object, which I call out object. And then I wrap all my kind of real code inside of a try catch block. So at this point, I'm using inline script, but I could also be using regular workflow code. And since this is inside of a try block, if I stumble upon some kind of error here, I also specify our action preference inside of the inline script, since that's a different run space. So any error I get anywhere in my code will cause this catch block to be executed. And inside the catch block, $_ is basically the error object. So inside there, you'll find a ton of info around the exception that actually happened. So we store that inside of a variable, and then we add that to this empty out object. And then we look at if these exceptions might have an error record, which among other things will record the name of the commandlet that caused the error. So if we have one of those, we will add that as well. So at this point, if this out object has an attribute called error, we know that this workflow failed. It contains some error. So in the other one, what I basically do is that I just look at, hey, if this guy had an error, then I know that something failed, and if not, I'll just go on. So in those cases where I call multiple workflows from a parent one, I always do this the same way, basically. So I just get the results, check if it has an error record. If it does, I'll just stop everything. So I'll write out the actual error and just return, which will cause the rest of the runbook to not be executed, basically. So I'll just stop here. So this skeleton allows me to keep track of any errors that happen and just stop the workflow running without actually any exceptions surfaced up. And the reason why we don't want to send exceptions up to SMA, to call it that, is that if you get an error inside of, or if you get a non-terminating error, the script will just keep on running, and that might be problematic. If it's a terminating error, the runbook will just go into a suspended mode like this. So you'll actually have to go in and either stop it or tell it to or resume it. So you'll actually store this suspended state inside the SMA database until you do anything about it. So that's also problematic, I guess. I wish there was some kind of flag you could set that said, hey, if a runbook has an exception, just delete it or get rid of it. But they don't. So this is part of the reason why it's super important to keep tabs of what happens in terms of errors. So I'll just see if I can find one that actually failed. Let's see, power state wrapper. Oh, we can look at one that succeeded first. So this is the verbose log inside of SMA. So as long as you turn on verbose logging, each job, which is an instance of, or yeah, each time you execute a runbook, that'll execute a job that will have its own verbose log. And this is basically all the output streams. So both output and verbose. And if you can also turn on debug logging, which will show the debug stream here. So let's see if I so for instance, this is the wrapper, but I call this child runbook called get dev environment details. So here I know I'm inside of that runbook, and then at the end of each runbook I also have ending workflow. So I know that at this point I'm back in the parent runbook, and then I can kind of trace the progress of the parent and the child runbooks as they go through their jobs. And if you find that some commandlet is too chatty, I have a lot of invoke REST method invoke REST method here. And if you find that they're too chatty, you can do, let's say, import module. I have some modules that I can use. Import module Azure, yeah. So if I import this guy, you'll see that import module is really chatty, but I can actually turn off verbose logging by doing verbose $false. Like that. So if at any point you feel like there's too much stuff here, there's stuff we don't need, you can use verbose $false to kind of turn off verbose logging for that commandlet. So that might be a good way to keep your verbose log nice and clean. And these logs also, SMA cleans up these logs. There's I think it's a config entry controlling how old it should, or how much of the logs it should keep before it starts flushing them out from the database. Because if you have a lot of jobs with a lot of verbose output, your database can grow quite big. But there is a built-in function that will take care of flushing them out once they reach a certain age. I can't remember from the top of my head what that default is, but I think it's inside this config file where, let's see. Orchestrator, diagnostics one. Or I think maybe it's this one. No, it's not. In that case, I don't remember. But anyway, there is a config file where you can control how old those logs should be before it starts flushing them out. So that's basically the skeleton we use. Everything inside of try-catch blocks with error preference. Sorry, error action preference. Sorry, turn to stop, which will make sure that any problem we get here will cause the runbook to not fail, but to report failure up to the parent one through this output object. And that enables us to nest deeper than the three-level nesting that is problematic inside of workflow if you use the regular error action preference. So the only thing I need to make sure of here is whether or not any of these commandlets are chatty if they output stuff. And I can also do some, so if here I expect to get an object back, and if I didn't get that object back, I can basically just throw an error, which will be surfaced up through that same try-catch block. So for us, this is a super robust way of writing workflows, and we kind of start off with the same skeleton each time. There are some subtle differences between the parent runbooks and any child runbook, because in the parent runbook we don't output that object. So at the end here I don't output anything. I just end it off basically because there's nowhere to send that object to. So we have this one skeleton for these parent ones or the wrapper runbooks, and then one skeleton for the rest for the other type of runbook. And also, if you need to report data back to the parent, you can use that same object. You can basically sorry for all the scrolling. I know it's slow on your end, but I can basically just take the same method of just adding an attribute to that same output object, which would contain data that I need sent back up here, and then I can basically access that the same way. And I also have links for that in my slide deck. So that's how we design these runbooks in order to keep it simple and not having to invent the wheel every time we create a workflow. So that's been a fruit of a lot of we definitely spent some hours coming up with that model and made sure that it kind of worked for all the stuff we needed to do, whether we use inline scripts or just basic native workflows. So that stuff is on this address, and that's sync runbook script that I use for publishing from my file system up to SMA, or basically syncing those files is also on GitHub. And lastly, this discussion around whether SMA should support real PowerShell has been flourishing on Twitter for as long as SMA has been out, and Joe Levy seems to be coming around now. So we have this hope that sometime in the future they start supporting regular PowerShell, which would make it a lot easier for us to work with SMA. So we'll just fold our hands basically and hope they come around as soon as possible on that one. I don't think they'll be able to support that in the 2016 version of System Center though, so we might have to wait for a bit for it. But in any case, to sum up, I guess SMA is, like I said, a really exciting product. It solves a lot of problems, but we are kind of bummed that it's using workflows instead of regular PowerShells because of all the bugs and the other problems we face with workflows. Workflows is also a lot harder to debug than regular PowerShell, especially inline scripts. You're not able to properly debug them in any way. So I have this discussion with Jeffrey Snover as well to kind of make him realize that either they need to beef up their workflow stuff or they need to basically discontinue it, because there's basically there's a black hole there that we need filled somehow. So we'll have to just wait and see what they come up with. And that is my slide, I guess. So I don't know if there's any questions from the audience.
Anybody questions? Everybody is in silent contemplation.
Oh, they're just drinking beer, I guess.
Well, unfortunately, we're at the Microsoft office, so they don't let us do that. But
oh, they don't. That's too bad.
I guess the one question I have, you briefly talked about a demo you were doing with building out like a Hyper-V environment. What are some other like real-world things you've used SMA for?
So right now we have two customers. They kind of share some of the same code base because both of them wanted a fully automated Hyper-V deployment solution. One is a offshore company, so they basically have a small data center on each ship. So what we built there was basically they're able now to just when they get their servers from HP, they plug them in and get an ILO address, and then they register that in this web portal. And then from there, SMA takes care of bare metal deployment configuration, setting up networking and everything, patching, and then they deploy these standard VMs on top of that, which uses I think they use Hyper-V replication. So SMA will basically do bare metal deployment and configuration, and then deployment of the standardized VMs, and then we call into some desired state configuration stuff to configure those VMs. They have one VM which is a domain controller, config manager, distribution point, I think a SQL server, an MDT share, and some other stuff. So that's basically SMA controlling everything. And then we use this web portal, which is also a web service, to kind of store all the data that's needed for configuring each host, or configuring the host on each ship. And then the other customer is kind of the same, but they're using System Center Service Manager instead, which is a bit harder to work with because of the relationship objects, but basically it's the same type of code. And then it's this project that I'm working on now, which is a bit smaller, where the customer has this, each developer gets access to what they call development environments, which contain Azure VMs, and then they're able to basically start and stop their VMs without touching the real Azure portal. So that's also just C# code calling SMA, which will execute the PowerShell scripts to perform the actual starting and stopping of those VMs. And the reason they went with SMA is that they are probably going to switch to Service Manager or something else in the future. So we wanted to kind of make sure that all the code for actually interacting with Azure wasn't depending on either C# or some product. So that's why we use SMA to kind of make sure that whatever product they choose, they can just call different runbooks through that web service to invoke the starts and stops and all the other stuff. And I guess from experience, I would say that last project is like a perfect fit for SMA, because it's not a terrible amount of code that goes into it. These are all, I don't know if you can still see, yeah. So these are all the runbooks. There's some here that should actually be deleted. And then there's some functions that will remind each developer that, hey, you have a VM that's been running for a while, so you should probably stop that. So for these small projects, SMA is a good bet, I guess. For these bigger Hyper-V deployment projects, if we were to do that again now, we probably would have chosen something else, because it's been quite costly to use workflows to develop that, just because of the lack of debugging we have, especially inside of inline scripts. So if I had to do that again today, I would probably advise the customer to find some other product, or just implement it using regular PowerShell. That would probably be a lot cheaper for them. So it's definitely a maybe product. It doesn't fit in every situation, but like I said, we hope that they'll start supporting regular PowerShell, so that we're not limited by workflow. And if they do that, it could be a really awesome product for basically any IT department, I think.
Last call, any questions? Were you able to hear that at all, Trond?
No, sorry, I wasn't. Could you repeat that, please?
Yeah, the question is just, if you're using Orchestrator currently, can you import those runbooks into SMA?
Well, Joe told me that they're building this conversion utility, and I asked him, "Are you sure you're not on something right now?" And he told me no. But basically, yeah, they're because a regular orchestrator is going away, and they're replacing it with SMA. What they're doing for the next version is that they are gonna lay this GUI-based tool on top. So I haven't seen it yet, but as far as I understood from my talk with Joe was that at least these simple workflows where you basically, I don't know, create a VM, stop a VM, start a VM, like basic standardized thing, you'll be able to sit in a GUI and design that around. And they're also, like I said, creating this conversion utility to basically take this orchestrator format, which I guess is some kind of XML, and converting it into PowerShell workflow. I don't think at least it might be a good way to like quickly convert something that you can start off with, but I don't think they will do much error handling in there. And like I showed here, that as when you start kind of linking runbooks together and you fall into any of these workflow traps, I don't know. Maybe for super simple workflows that will work, but for complex stuff, I don't think there's. I think you'll have to kind of create them from the bottom up. But it might be, maybe you'll get some code that you can copy paste in at least. But I kind of have my doubts about how well that utility is going to work in real life. Yeah.
Is the Microsoft guys using all the cats and the I don't know if you want to play.
I didn't hear any of that, but the gist of it was he's been told by the Microsoft guys in the building that we're in that it's kind of working at this point, but he wasn't sure what the integration was with System Center or anything else. So we'll have to see what happens with that.
Yeah, no, I'm sure it's going to work. I'm just worried about the quality of the code that utility will produce. So I'm sure it'll be executable code. I'm not sure I would want to put it in critical production. But like I said, it might produce something that's a really good starting point. Maybe you can just add some error handling to it manually, and then at least you're off to a good start. But yeah, part of the reason I'm saying that is that the automation team is putting out a lot of really good examples. They have tons of examples in what they call their, I think, automation gallery, which is part of the TechNet script gallery. And if you look at that code, there's basically next to zero error handling there as well. So I'm just a little bit worried that they might be taking error handling a bit too lightly. So that's also a discussion. I've asked them to kind of implement some best practices around error handling when they write their examples. But I'm sure that the code that utility will produce is runnable. I'm just worried about the quality, basically.
Gotcha. All right, well, we're out of time, so we're going to cut you loose. I know it's late there, so thank you very much for the presentation.
No problem, my pleasure. And I'll email it to Jacob, I guess, and he can just distribute it if anyone wants the links or whatever.
Okay, sounds good.
All right, good stuff. Thanks, guys.
Yep, talk to you later.